Alright, well, hello again everybody. I hope you're missing me. I hope you enjoyed the video about balancing chemical equations. There's some things I really like about the video. The number one thing is with that teacher there, his first few examples, he used different color spheres to help you see how they start off not balanced and what you have to do to balance the equation, just like I did here. So as you can see, we have a different number of blue spheres on this side, which is our 3 hydrogens. There's only 2 over here. That's a problem. And on this side, our product side, we only have 2 of the yellow, our nitrogens. There's only 1 nitrogen atom on the reactant side. Now, in order to be balanced, the atoms on each side have to be conserved. That way, mass is conserved in our chemical reaction. Now, here's the one thing I didn't like. The teacher used a lot of phrases like, this is what I notice when I go to balance this equation, this is what I would do. I want to give you a series of steps, which I have over here. I'm going to turn the camera and zoom in and have you write these steps down. It's just like what you should think about in this order, and it should help you get a balanced equation every single time. Now, the one thing I want to repeat, he did say, if you mess up, just erase it and start over. It happens all the time, okay? So I'm going to take a moment, I'm going to zoom in over there. On the back of that half sheet of paper you have, I would like you to copy these steps, and I would like you to use them and think about doing the balancing in this order. So copy this down here. First thing you're going to do is I want you to look at your equation and underline polyions that are in it. Hopefully at this point you can recognize a polyion. The nice thing about this is if the polyions are the same in the reactants as the products, you can balance them as a whole chunk and it'll make your life a lot easier. What you do after you underline that, you can balance any atom, not hydrogen and oxygen. It doesn't matter in what order. The key thing is you want to do the hydrogen and oxygen at the end. Third step, if you have polyions, balance it after any atoms that are not hydrogen and oxygen. You would do those next. And then the last 2, sometimes you have to switch these 2 steps around. Usually what you want to do is balance oxygen first and hydrogens last, okay? And that should be the order you go. Sometimes you're going to switch these 2 around and balance the oxygen last, but you do that if you see O2 somewhere in the reactants or products. You're going to find that usually if O2, oxygen, is somewhere in there, you're going to balance the oxygen in that last. That didn't take long at all for me to fix back, did it? Okay, so now we got this right here. This is the second one on the full practice thing that you have. I decided to do this one first because it's a little bit shorter. Let's start easier and get a little bit harder here. What I do, as opposed to writing down the atoms on this side and the atoms on this side, I find my arrow. And I write down all the atoms that I want to balance, and I do it in the order of my steps. And I just do it right here in the middle. I would do the nitrogen first and the hydrogen last here, okay? And what I'm going to do is I'm going to write right next to each how many are in the reactants and how many are in the products. So in my reactants I have 1 nitrogen, and in the products I have 2. And I'm going to do it just on this side, just like that, okay? And then with my hydrogens, I have 3 in the reactants, and I have 2 in the products. All right? And this is the order I'm going to think about. All right? Any atom not hydrogen, I'm going to balance first. Okay? So what I need is I need 1 more NH3 here for a total of 2. So that will balance out. So let me grab second NH3 there. Kind of handy how I had that right there, you know. I'm prepared. All right. The problem is at this point, while my nitrogens are good, my hydrogens are not. I changed them here, so I better change this right here to a total of 6. You got to multiply your coefficient by the subscript going with that hydrogen for 6. So I need a total of 6 here. So what coefficient will I put right there to get to 6? And the answer is 3. 3 times 2 is 6. So I need a total of 3 H2 molecules. And I like seeing here that, yes, the different colors all work out. My atoms on the left equal my atoms on the right. Okay. Now let's do one that's a little bit harder. This first one here on that worksheet. And what I do is I do have a polyion, my OH, but the thing is I don't have OH like that in the products. So underline it's not going to save me any time. I promise you I'll do an example where we have polyions in both sides. So the order I want to do it then, it's any atom not hydrogen and oxygen. So I can do the calcium first or the chlorine first. It doesn't matter. I'll just go in the order all the way to the left. I'm going to do calcium, then I'm going to do chlorine. Then according to our steps, we should do oxygen and then the hydrogen last. So I'm just going to kind of balance this as I go. I got 1 calcium in the reactants. I got 1 calcium in the products. I got 1 chlorine in the reactants. I got a total of 2 in the products. I'm going to change that right now before I go any further. I'm going to put a 2 here, a coefficient that goes to HCl, and that would change my chlorine there. Next thing I'm going to look at is oxygen. I got 2 into the parenthesis there, it distributes. 2 times 1, I got a total of 2 oxygens. And on the right, I only have 1, okay? So I'm going to have to fix this right here. I want to make this 2 by putting a big coefficient in front of the water here, H2O. And so now I have 2 there. And now the last thing I want to do is I want to make sure that my hydrogens are okay. Over here, I got 2 hydrogen right there, plus I have 2 hydrogen right here, a total of 4. And the nice thing is, if you follow my steps, hopefully you'll get to the last atom here and it'll be okay. 2 times 2 is 4 hydrogen. Nailed it. All right. And if you follow this order, usually that works. All right. Now I'm going to take a second. I'm going to erase this. I'm going to do one more example that has some polyions, and then I'm going to let you practice with the teacher. And the one I'm going to do is the bottom of the front page of your worksheet. AlBr3 plus potassium sulfate, K2SO4, forms potassium bromide, KBr, plus aluminum sulfate, Al2SO4, 3. I need to check and make sure that you can see it. Give me one moment. Alright, looks like you should be able to see that. Alright, no problem. Okay, so first step, underline the polyions, because if they don't change, you can balance them as a group. SO4 sulfate, SO4 sulfate. That's going to make our job a lot easier at the end here. Right? So let's now figure out the order. I'm going to go right down the middle with my arrow here. Any atoms that are not hydrogen and oxygen, I got aluminum, I got bromine, and I got potassium. The sulfur and the oxygen is part of my sulfates. I'm not going to do that. I'm going to do sulfate together, as you're going to see. So we might as well start with aluminum. And then bromine, and finally, well, not finally, after bromine, potassium. And the last thing we're going to do here is do the SO4 together. Now, before I start balancing, I want to explain what we have here. There's no parentheses around our SO4, so that's meaning that there's only one right here. Okay, they don't write the parentheses if they're only one. But how many do I have in the product side? I have a total of 3. Okay, I'm going to want those at the end to match up to be the same number. So hopefully you can see 1 SO4 in the reactants, 3 in the products. Now let's just start balancing with our aluminum. I have 1 here, but I have 2 in the products. So I'm going to stop. I'm going to fix my aluminum before I go on by putting a coefficient in front of my aluminum bromide. Now, I have bromine. I have a total of 6. I have only 1 here. Okay. Let's fix it. The one that has less, that's what we got to add to. I got to get 6, so put a big coefficient in front of that whole formula with bromine. Right. So now we take a look at our potassiums. I have 2. Right. I have 6. Okay. So we got to make this work out. 2 times 3 equals 6. And now, if I'm not lying to you, hopefully our sulfates end up being equal. I have 3 as a coefficient in front of potassium sulfate. It did work out. Okay? So good luck. Don't get frustrated. I will help you later on with this. Sometimes you have to go back and change something that you have already balanced. That's okay. Just change it and go on. I would say if there's going to be a step 6, is you want to double check at the end just to make sure, yes, indeed, all your equations are balanced. Okay? All right. And just a reminder, I am somewhere cruising the Caribbean, and you are not.